Group leader, I shall be recording.
Sigma.
Um, so we are doing TS
No,
packet.
we are scrolling reels.
Never goon. Oh my god, the first 5 minutes of the video gaps can be absolutely horrible. But does it really matter? We're having fun. Ben, why is your PDF file so corrupted?
I don't know, bro. I just emailed it to you. Okay.
I
Don't shoot the messenger. Shoot the message.
okay.
It is completely fine on my end. Why don't you just like screenshot that? Oh,
So I'm gonna share with you guys. Then we're going to okay. So we're yeah. So what's the inductance when the current increases to 1/3 its final value in 30 seconds? So E over R equals to equals I equals negative L times DI. So it's
wait.
approximately
What? Wouldn't it be negative L times DIDT times R?
over R.
Yes. My fault.
Okay, so essentially what we're gonna do is so DI dt, and so change in I is so 1/3 I over 30. And so we cancel the i's on both sides. 30 approximately 99. So what's the rate of change in the current in the inductor when the current in the battery is 0.5 amps? So E di dt,
Wait. The answer for number one is A.
1/3 its final value. Did I drop a number? Oh, so sorry. L equals
I think you.
E
Yeah, yeah. You have
times
to use the.
T over delta I. Sorry. So we just do this.
Wait, where's that? Where does that come from?
That's just, I think, if you take the
Oh
integral
yeah,
of
yeah.
this
No, never
equation,
mind,
like you
never mind,
just
never mind.
rewrite this equation. And so delta I equals z 1/3 I. And so, I don't know.
I have a what I used to solve it was like there's this equation where it's like the current is of at a certain t is equal to the final current times 1 minus e to the
Oh, it's
negative.
that equation.
Yeah.
Is it like this one times
Um
like 1 minus e to the negative?
yeah, yeah. RT over
Okay,
L.
so yeah, that makes sense. And this is just equal to I final, and I naught.
Wait,
And
is that true? I thought I naught was replaced with I final.
this should
No,
be
I
I final. This is I naught.
isn't I final like the isn't that a function?
Sure, I don't know. Maybe I'm
Yeah,
wrong.
I final is a function. So the graph looks like this, right? Because as the inductor, it's initially 0,
True, true,
and
true.
then it does the thing.
But you're not.
Goes to induct.
To induct is to oppose the flow of current. So it starts at 0, and then it goes to a steady state, which is just like this equation, because this goes to 0 after a long time.
Okay, I.
So equals I naught, so 1/3 equal equals 1 minus e to the negative RT over L. When you solve, look, you don't want to solve all that, but 2/3 equals ln of that equals negative RT over L,
Wait, where do you get 2/3 from?
because you subtract 1, right? So negative 2/3.
I might be smart. Never mind.
Do that. I go this way, you go that way. I go this way. ln 1.5. So RT over ln 1.5 equals to L. That should give you 0.74.
Yeah, yeah.
That should. For the circuit shown was the rate of change in the current, so you just use this equation. When the current in the battery is 0.5 amps, so this is going to be 10 volts is a potential difference. So E is equal to 2 volts.
Suck it.
So
Arena
2.
asked if we can go over that equation with the e in it. I naught times 1 minus e to the power of negative RT.
Okay, that is next.
Oh,
We're Loki just flying through them as
Oh.
we go. Hello,
okay.
taper fade. So 10 millihertz times di over dt.
Then what is that background, bro?
And so it gets you, I think, 200. Then potential across the capacitor is 400 volts. The instantaneous current
It's my glorious king.
is 0.7 amps. So you have two energies, right? 1/2 CV squared, or essentially. And so before the switch is closed, it's 200 volts. So E naught is equal to That's equal to 4 times 4 times 10 to the negative second. So that's going to be our initial energy, 0.16 joules.
Wait, what's that equation from?
This is equal to the energy of the
Oh,
capacitor.
1/2. I might be smart, guys. Never mind.
Okay. We all make mistakes.
I thought you wrote like F as like a number. My bad.
And
Capacitor.
then energy is equal to, so 0.16 minus 1/2 L I squared equals to E of capacitor. Whatever that comes to, because I don't feel like it. That's 0.7 squared, so 0.049 over 2 times 0.2, so that's it's zero point 0.1, so 0.16 minus. I dropped a decimal here.
It should come
Okay.
out to 31 millijoules.
1/2 Li squared is what again?
The energy of the inductor.
Okay, thank you.
So 0.49 divided by 2 times 2. 16 minus 49. That's the energy in the inductor. Does anyone have a calculator so they can do it?
I did it like last night and it
Okay,
was
so
beat.
31.
Yeah.
That's just the expression. So energy not equals to E of the capacitor. Energy final equals E of the capacitor plus E of the inductor.
May I ask a question, Master?
Yes?
Can you go back to number one, I think it was?
Uno. Of course.
So for the equation with like E and like that stuff, is there like a parallel equation that you would use for LC circuits? Or is it just RL? Like you would use
For
one here.
LC circuits, you're gonna have the because our L circuits operate. Let's draw a diagram of both of them while we go into the derivation. So, right now, your derivation is up next. So, this is an LC circuit, right?
So no battery.
No battery, just a capacitor.
Can there be a
And
battery, or is like
no,
there?
that's against the rules.
Gotcha.
And then an RL circuit is going to be something like,
Or it could be in series too, right?
yeah, it can be in series, just like something with an inductor and a resistor, and maybe a resistor here.
Okay.
And so the main difference here is there's a constant power source. We have our battery here. So here there's a constant like the reason there's a differential equation is because this E is equal to, in this case, it's because the capacitor sends charge over to the inductor, and then the inductor opposes it with an induced current and sends charge back to the capacitor, and they play catch, and it's simple harmonic motion of
Okay.
current. There's charge going that way and charge going this way, and that's why these are two completely different
Right,
things.
right, right. Are there any equations for the one on the left that we should know?
For the one on the left, know the energies.
Yeah. Like any like angular equations with like cosine or whatever.
The thing is, you need to know calculus 3 in order to fully derive those, as well as differential equations, to fully derive the equations for this situation, as well as it parallels the simple harmonic motion you find in unit 6, where you can't do it without like
Yeah.
you have a y dot, and a y double dot all at the same time equals to something, right? And so you
Mm.
can't do this with Calc 2. You have to do this with Calc 3, which is why it's not tested on the
So
exam.
do we have to just memorize the equations?
No, you don't want to memorize the equation. You just want to memorize the energies and the concepts of an LC circuit. You want to
Oh,
memorize that it is in simple harmonic. So things you need to know: energy. Second, SHM. Don't know equation. Don't know the derivation. You can know the derivation, it just doesn't. It won't put to any use, as much use, just because it's not nearly as
Okay. Going
useful.
back. Oh, sorry. Going back to the one on the right. Is there a equation for discharging it, or is there just one for charging?
Which one? On
The
the
one,
right?
the RC,
There's no real
or
equation for
RL. Sorry.
discharge. I mean, yeah, you could take it as like there's current flowing through here, and then once you take out the battery, it starts flowing around. Yeah, there is. But that would involve Kirchhoff's loop rule, and so that would just be I times R equals E naught. So the graph would essentially look like something like this. You're gonna see, let me draw I. This is like T1, right? This is I resistor, I through the resistor. The inductor is going to keep it constant, but then it's going to go to 0 eventually. Because the resistor dissipates the energy in the inductor,
Hmm.
and the voltage drop would also follow the same pattern.
Okay.
Because
There's no equations we should know how to derive or memorize.
not exactly. And so let's do our, what color are we using? Chat, what color are we using?
Brown.
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 Dark
This is going out to Joy. Why it's an simple harmonic motion. So they're basically playing catch with the charges. So the capacitor discharges current, and then the inductor sends an induced current back to the capacitor to recharge it. And so they send it back and forth to each other. Yes, Rena's right. Know that like Q oscillates. That she posted an equation in the chat. Q equals Q cosine WT. I haven't seen this on the exam as well, just because it's much more niche than a lot of other topics. But what you probably do need to know is this. So we have our battery,
And
positive, negative.
you need to know that omega is 1 over square root RC, right? Or no, not RC.
That's tau, I believe,
Sorry.
right?
Um, wait, what is omega?
Omega is just a phase shift constant. It's just like a K or an L, pretty sure.
Wait, I thought tau was equal to like not that.
I thought
Tau,
omega had a specific value. Is it not 1 over square root L times C? I thought that was something. I don't know.
that might be. I'll try to remember. But in the meantime, we're doing this problem. So we have a current, right? I, but initially we have an open switch, a resistor, right? And then we have our slinky, which is also called an inductor. So at time t equals to 0, the switch is closed. And I through the resistor equals to 0. And then when the switch is closed, t is greater than 0, we have to obey Kirchhoff's loop rule, which states V of battery E, referred to as epsilon, equals voltage of the resistor plus voltage of the inductor. Which this means that the E is equal to the resistance times the I final plus L times di dt. Stop me anytime you have any questions. V or E minus R I final equals L di or dt. So then we separate our variables to get di t. And then when you fully separate them out, you get negative dt over L, and this is multiplied by R, equals, I think, this way, that way, I go this way, di t over E minus E over R minus I of t. And so when you integrate that, let's say from 0 to t, or what I prefer is the indefinite integral. So negative t R over L equals ln I minus plus C. If you were to do it definitely, you'd get that's equal to ln I minus V over R divided by negative V over R. And then the next step is to essentially take the exponent. So C times, so we can pull this out. Sorry, quick mistake if you caught it. Negative T R over L times C equals I minus V over R. So V over R equal plus and because I naught equals to 0, what we get is C equals to negative. So it becomes V over R times 1 minus e to the negative t r over L equals I final. Questions?
Yes. Okay, wait, so that thing next to an E that looks like a C, is that an I?
Which
Like
one?
go down a little bit more. Thing next to an E that looks like a, yeah, that looks like a C. Is that an I?
No, it's just a
Oh,
C.
that's a C. That's a constant of integration.
Okay, and the lowercase I, is that a capital I?
Yeah, it's the same as I final.
Happiest plus C forgetter, bro.
Alan remembers the meme. Those who know.
Those who know.
Okay, wait, can you scroll up a little?
Scroll, scroll, scroll. Reels, reels, reels.
Or scroll.
Hop on the website, bro.
Oh, true. Hold on.
Never check the chat.
No, I did check the chat, I just thought it would be easier.
Don't check the chat. You're wasting your time.
Okay,
Okay, so we are gonna go through this step by step again. So first, we have our diagram.
yes.
Do this in. There's no pink.
What's wrong with brown?
Is this racism?
Doesn't count.
Self-hatred
So one, we have our drawing. Two,
thing.
Kirchhoff's loop rule. E equals V of R plus V of L.
Yes.
I'm gonna leave out most of the steps in this derivation. So
Okay.
three, we substitute in E minus R I final equals L di over dt.
Okay.
Then four, you guys can do all the algebra yourselves. So integral,
Wait, wouldn't they just cancel though?
What if you're terrible at integration?
Am I stupid? Wait, what do you mean you sub it in? Like how?
so V of R equals to R times I final, and V of L equals L times di over dt.
Oh, you mean you sub? Yeah, yeah.
Yeah, yeah.
Okay, sure. Yeah.
Equals di.
What? Wait, how do you get there? I'm sorry.
Yeah, you had me lost at step 4.
Wait, how do you get to that like equation though? Like
So you do a ton of algebra,
a ton? Like
you do a massive amount of algebra with this equation,
can you like do that? Maybe. Sorry.
PMO.
I'm actually slow.
Okay,
You know
so
what else is massive?
E
Yeah.
E over L minus R I final over L equals di dt. Make sense?
True.
So V over R minus I.
Wait, where do you get V over or
So we're dividing both by R. Divide by R, divide by R,
and times by L?
and multiply by a big R in front.
What?
What?
It's just for simplicity's sake. You'll trust me, bro. Trust me.
Yeah, it's not simple, bro. Where did the L go?
So
I ate it.
then I put the L at the bottom,
Oh.
and then we divide that by R.
Wait, shouldn't the I be over?
Because that's the same as multiple. Putting the R all the way down here is the same as, you know what? Let me just put it out here. Times R. For convenience.
Wait, the
Equals.
equation on the top is messing me up now that you changed it with the R's. What was it before R?
So E over L minus I R over L equals di dt.
Okay, yes, I understand everything, or the yellow stuff now.
And so once we do that, we basically have to separate the variables to get di equals to dt times R over L, right? Times V over R minus I. So then this goes down here, and this stays by itself to get the integrals dI over V over R minus I. And that's negative dI's.
Isn't V over R also I though? Like, what's the difference?
It is.
I of final, this is the
Uh,
function, equals to dt R over L.
If that meant true.
true. Okay.
Negative as well. And so
Those who
then the next step in the operation is to take the integral. So then we get negative t r over L equals ln I of final minus V over R plus C. And then you just simplify that to get the final equation. You just solve for I in this equation to get I of
Wait,
final.
how do you get the ln part? Like, what was that?
Because
That's
that's
just
just
integration.
integration.
That's
With res
provided to you on your formula sheet.
with respect to I final?
With respect to I, yeah.
Wait, Saki, can you pull up the formula sheet for physics?
So integral of 1 of dI over I over dI equals ln I.
Yeah, no, no, yeah. I just didn't know if it was okay. Because you like when I see like something final, I usually think of that as like a
Yeah.
constant like, number.
What you can also write of is I of t.
Yeah.
That
Okay.
might also help you. But then that gets you this equation I of t
Okay, I understand now.
equals to that.
Then you just do
Does the
algebra.
chat have any more questions? I'll take that as a no.
Great, Ben, I sent in chat.
I'm no, I'm yeah, I'm aware of how to do the integral.
Okay.
I just
Group leader has posted the integral.
do you think it's fine if we just like memorize the formula?
Yeah?
Like, 'cause you wouldn't ask us to like drive it, right?
So the thing is, on AP exams, one of the points will be for getting this equation,
Uh-huh.
and 5 of the points will be for getting the correct bounds of integration, the correct constant of integration, and all the way up to that part.
Okay,
Most of the points will in fact be for work and not for answer.
but
So
I
what
can
are the
take
bounds?
50 points, right?
If you were to do bounds, it'd be from 0 to t and from 0 to I final.
Okay.
TS makes sense.
Who wants to do an LC circuit and do Calc 3?
Nobody.
Not a single person.
That can't be right.
Message from the chat. This test will in fact be easier. This
Then
test, I'm telling you, if the FRQ is the same, it will be easier than the previous test.
if the how's it gonna be easier if the FRQ is the same?
As last year.
Yeah, so like how would it be easier than last year if the FRQ is the same as last year?
Easier than the last test.
Oh, I see.
Much easier than the last test. Because this unit, if he decides to make the if the LC circuit is supposed to be, or the RL circuit is on the test, just you have to know the derivation.
Like this derivation?
But normally, it'll always be an inductance on a bar problem.
Inductance on a bar?
How does one do that?
Moving bar problem.
With inductance?
Yeah, the moving bar problem where like it resists and Lenz's law and does the thing that we were doing yesterday.
Yeah, but do we do that with inductance or just resistance?
That was inductance because like resisting the change in flux is inductance.
Can I get a quick recap?
Oh,
For a
wait,
quick
okay.
recap, please watch yesterday's video.
Oh shoot.
Quick advert,
Wait,
quick
wait,
shame,
so
quick.
it's not only inductance if there's an inductor, but if there's an induced
Yeah.
EMF, that's also inductance.
So an inductor is just a thing that inducts. Inductance is a phenomenon.
Inducted it, got it. Thank you, Socket. I feel like at the end of the year, like all of our grades are going to be like 20 points higher because of you.
Real.
I got you, GNG.
Me after I barely passed with a 3. You still get an A if you pass, right?
This meeting will be stopped because 2 minutes is not enough time for the next question. Also have to save the recording. Please rejoin the meeting in approximately 10 minutes
10 minutes.
while I remake the meeting and everything.
Okay.
Will Massa Socket resend a message in the Discord when it is
Yes,
ready?
I will.
Thank you, Socket.